So today I wasn't sure what to explore or fix in my video, so I was walking my dog and I saw this next to a dumpster. So that's it. Today let's explore this vacuum cleaner. Maybe let's even try to fix it, or at least let's see what's inside of it. And how does it work? This is a battery-powered vacuum cleaner full of flammable toxic batteries. They inevitably wear out and can't be really recycled. The mining of the materials is very environmentally questionable, but anyway. Of course, for myself I prefer a mains-powered vacuum cleaner. I don't really see a point of using batteries when you have a wall socket just a couple meters away. But on the other hand, this one is definitely much more interesting to explore. It will contain way more of it to learn from than a mains-powered vacuum cleaner. And also way more of it to go wrong. Let's start exploring it. Delta Vision, all floors, active motorized brush, Extreme Cyclone, no bag, Lithium Pro, Extreme Cyclone Technology, Air Force Extreme, Vision Pro, Pro Charge, Turbo. How many more buzzwords you can put on a bloody vacuum cleaner? But anyway, it has a switch here, so let's try to power it. It has 4 positions, probably off, minimum, medium, turbo, and it's blinking here. I guess it's discharged. The question is why it was trashed. Are the batteries worn out, or some of the other circuitry is bad, the charging circuitry, or the motor? We will disassemble it and see, of course. And it has a charging connector here to recharge it. But what actually surprised me was that right next to it was this adapter or charger, which actually the connector fits into it, but it doesn't seem to be for it. This one says brown. It's a completely different maker, different style, different color, different era. This looks like an iron transformer. Appears much older than this one. It almost made me think, did somebody actually use a wrong charger where the connector fits, but the voltage probably isn't the right one, and did somebody trash it just because he tried to use it with this charger which didn't work, and so he trashed it? That's possible. People are sort of dumb, and they think if the connector fits, it has to be compatible electrically as well, don't they? But anyway, let's try to see the internals. Some more in the handle. And do I have to remove this thing as well? I generally don't use this, but I might be lazy today. Of course, these holes are too deep anyway. I'm not sure what this one is for. This thing should probably also come out. This is how you clean it, isn't it? Or maybe somebody trashed it just because it was dirty. It would be no surprise in this disposable society today. This thing comes off, making it a bit smaller. Is there anything electronic? Well, there are some contacts. I guess there has to be something electronic in this. 25.2 volts, 25 watts. Is it the power of the entire vacuum cleaner, or just something inside of this thing? Can't imagine a vacuum cleaner using just 25 watts, even though maybe with European energy consumption restrictions. Maybe it's a good idea to look at some instructions. 1, press down. 2, tilt out of it. Yes, of course. So here's where the dirt is collected. Some filter. And there's some label. And it says adapter 36 volts, 400 milliamps. Okay, so this one is definitely not for it. This one says 12 volts, 400 milliamps. So if somebody tried to charge it using that charger, it definitely wasn't going to work. And 25.2 volts batteries, that's the lithium-ion battery pack. And this number divided by 7 is 3.6 volts. So I guess it's 7 lithium-ion batteries in a series in it. And of course it's stupid to say the voltage on it. It doesn't say anything about the actual capacity or energy in the batteries. If they said something like 50 watt-hour battery pack, it would make actually some sense. I still have no idea how am I supposed to open it. Well, maybe this helps. Is there any electrical connection between this? Well, There are again two spikes going into these two holes here, two screws, and here is the charging electronics and the battery pack. Made of probably 18650 batteries, LG. A nice battery pack for free, isn't it? Of course, given it's not completely rotten. Here's the label of it, 25.55 volts, 2000 milliamp hours, 51.1 watt hours. So here's the watt hours actually. That's the interesting thing I actually want to see on the product. Is there any date code? 2017-07, so it's about 6.5 years. The question is, are the batteries rotten after this time? And here are the two wires going to the motor, and the battery pack has the red and black, overall positive and negative, then another 4 wires. If it's 7 cells in series, I'd expect 6 balancing points in it, but there might be some active electronics built into this. Some power transistor, probably switching the motor, some charging balancing controller, battery monitoring something. Let's take a look at the other side of the board, of course. Here's the switch for positions. It's lighting up some annoying blue LED for your maximum sleep quality, of course. This indicates the 3 power levels and 3 stages of charging or states of charge. And it's interesting how one wire actually goes into the handle and touches your hand. Is this to prevent some electrostatic charges and electrostatic discharge shocks? Probably yes. I can't see any other point of this. Let's take a closer look at the board here. This is probably just a MOSFET. Several transistors. Here the LEDs. Some capacitor, diode, resistor, transistor, couple resistors. Some diode for polarity protection, I guess. And now let's progress to the section of it with the motor in it. Is the air blowing out here? It has to go through the container first, I guess. So now let's open the motor of this Super Ultra Max Vacuum Cleaner 3000 Plus Professional. And if you call immediately, you get another Super Ultra Max Vacuum Cleaner 3000 Professional completely for free as a free gift. Of course, more screws here. Here are the 2 connections, probably to some small motor in the bottom part of it, I guess. And now this opens. Just 2 wires going in. And they actually also continue to the other motor. Here's the motor. It's really a huge motor for a vacuum cleaner, isn't it? It seems no active electronics in this one. Just the motor plus some interference suppression board. I guess some inductors and capacitors, nothing else. There's some impeller here. This just comes out. Here's the board with no active electronics, just interference suppression, and the impeller here in this module. And that's basically it. But now, of course, let's try to identify what's actually wrong here, if there is anything wrong. I will try to power the motor to see if it runs. Let's use my big DIY bench power supply, which goes up to 60 volts and 40 amps. I set it to about 25 volts. I have no idea what current draw to expect from this motor, but the power supply can go up to 40 amps. Should be enough. At 25 volts, this is 1 kilowatt. Does this look like a 1 kilowatt motor to you? Of course, the polarity should be right, ideally. Given the battery pack is 2 amp hours, the operating time of it should be slightly under half an hour. I don't really see any problem with the motor, so the problem has to be either the battery pack rotten, or the charging board faulty, or really just a bad charger. Okay, the connector fits, so let's cut this off the charger and connect it to a bench power supply set to 36 volts, and let's try to charge it. It says it's charging at 400 milliamps, which for a 2000 milliamp hour battery pack should mean about 5 hours charging time. Of course, I forgot to test this part. Nothing. I guess there used to be some sort of a motorized spinning brush in it or something, which was helping to collect the dirt. Okay, it also goes to base. And that's it. Nice. Quite clean inside of it, of course. And here's a small motor in it, which is a timing belt on it, and it spins. Probably the motorized brush, which is now non-existent. And there is some LED indicator, some LED illumination to make it look much more posh. Well, that's it. Is this motor bad? Why it's not spinning? Nothing. There's some tiny board. Is there anything electronic on it? It looks one transistor or something on it. So this is the cable going in from here. It goes into the board. It actually doesn't go straight into the motor. There is some sort of, is it a PTC thermal fuse or reversible fuse? The positive goes through this, not straight into the motor. There is also a cable going to the LEDs and this transistor or something. Let's connect the voltage straight to the motor here. And it's spinning and the LEDs are lighting up. So is this board faulty or is it actually turned off by the electronics for some reason? As the motor isn't actually connected via the transistor, it's connected to the supply voltage just through the PTC fuse. And the PTC fuse is 0 ohms, so the fuse is good. Why does the voltage not make it into here? The positive goes here, the negative actually doesn't make it to the board. Well, so is the cable broken for the negative going from here to here? Let's further open it here. Well, I guess this cable just came off the connector here and that's it. Well, now both of them came off. I guess the red one was just about to break off and the black one was already broken. And that's why this motor wasn't getting its voltage. So the main motor maybe was running, but this small motor for the brushes wasn't running. And this might be the reason it was trashed. Or it was maybe trashed just because somebody was too lazy to clean it. There are some interference suppression inductors, I guess, in these heat shrinks. So there is a conductivity from this wire all the way to the board, but it was broken off this pin. And the small motor draws 200 milliamps. And the voltage going to the LED board, this is 4 volts. So I guess this package is a 4 volt regulator, which is actually used for the LEDs, not for this motor. The motor is 24 volts. Now let's see if the battery pack can be still charged. Let's figure out the polarity of this connector. I was looking at this to see if it's center positive or center negative, but I probably expected too much from modern electronics. At least the cable going from the connector to the board is color coded. Center positive, the other one negative. So this wire is the positive. So let's mark it. Of course the NOT works the best. Now let's use my bench power supply. Setting is to 36 volts. Half an amp current limit. And this is now going to the connector. And let's try to connect it here. And it's indicating charging. Nice. I should have measured also the initial voltage of the battery, I guess. Before the charging it's 20.6 something volts. Which means if it's 7 cells in a series, it's barely 3 volts per cell, which is of course a completely discharged lithium-ion battery. So let's keep charging it. And the bench power supply is actually working in the current limit mode. When I disconnect it, white lamp. When I connect it, red lamp. So was the current limitation actually part of the charger, not this board? I guess it was. When I set it to 0.2 amps, it draws 0.2 amps. When I set the current limit to 0.5 amps, it draws 0.5 amps. The current limitation was probably the part of the charger. And if I set it to 0.8 amps, it actually stops charging. And the LEDs are flashing like this, probably indicating some problem. And now it actually doesn't draw any current. So let's go back from 0.8 amps to 0.5 amps current limit, disconnect it, reconnect it, and now it's charging. And and you can see it actually pulls down the voltage of the power supply. So the board has no current limitation built in, the charger has to limit the current. It basically just connects the charger to the battery pack and monitors the voltage, and disconnects it probably when it reaches a certain voltage. And the voltage on the battery pack is slowly going up. And this bench power supply has a stepped current limit selector, not a continuous adjustment. Now it's charging the battery pack at half an amp, which should take about 4 hours to charge it. And there seems to be some polarity protection diode and a transistor here. And this is in a series with the negative of the motor. This can basically turn it off. The switch is not turning off the full current of the motor. It's actually switched by the transistor. And it also can disconnect the motor when the battery pack is empty to prevent a too deep discharge. It's not like the older nickel-cadmium tools where the motor was connected to the battery pack just using a switch and it would basically discharge the battery pack down to zero. It was possible with nickel-cadmium, but lithium-ion batteries must never be discharged to zero. Now it's at about 30 volts and the fluctuation is the LEDs blinking actually, still in the current mode and charging at half an amp. And the battery pack is 26 volts, so it's not the full voltage coming in. There is about a 4 volt difference. So the battery pack kept charging until reaching this voltage and then it stopped. And of course when the charging current disappears the voltage goes back down a bit. It went to this in 10 seconds, to this in 10 minutes and to this in 32 hours. And the battery basically charges until it reaches the point it turns off the charging and then the voltage basically settles at a certain level like this. And normally when charging lithium-ion batteries, the charger first charges them at a constant current and then a constant voltage. Well, this one uses just a constant current and then it stops. And this of course makes the voltage go back down a bit more. Now let's try to connect it to the motor. Or let's try this switch first. Another set of retina burning super bright LEDs. Now it's all reconnected. It also connects the small motor. And it says 65 minutes. And the battery pack is 2 amp hours and it draws 4.5 amps at least. It was measuring about 4.7 amps or 4.5 at 25 volts. And this gives you 0.44 hours of operation times 60 to be in minutes, 26.6 minutes of operation, not 65. Maybe in the low setting actually. Maybe this is approaching 65 minutes from a massive distance, about 43 minutes. Out of curiosity, I cracked this one open, and here's the impeller in it. And it's crazy fast. Can I measure the RPM of it? I painted a silver mark on it and the rest of it black, and shining a strobe light at it. And I synchronized it at about 260 Hz, and the LED is powered using this function generator. So it's 15,600 RPM in the high, this is in the lowest setting, and 10,500 RPM in the low setting. Actually the small package on this board is a transistor, so the power supply of the LEDs is made of discrete transistors, it seems. But this entire part of it is a stupid design. The wires going to it from these pins actually go through this pivot, and every time it turns, the wires are twisting. Of course the wires fell off the pins here. Then the small motor lost power and the rotating brush stopped, and that's why it was missing. And they removed it because it was not running anyway and it was just in the way. and later they trashed it maybe because it wasn't efficient enough without it, or maybe they lost the charger or the charger stopped working and they tried the wrong one and it didn't work, so they trashed it. And this charger is completely unrelated, but out of curiosity let's take a look into it, and of course these screws are totally going to stop me from opening it. Here's the marking on it, and let's open it. And of course it's an iron transformer, a bridge rectifier and some capacitor, and that's it. And this was probably for some shaver, I guess. And of course shavers used to have an adapter powering the motor in it, but now they're using chargers and batteries. Which doesn't make much sense because you have a wall socket in every bathroom for the shavers for gentlemen and for hair dryers for the ladies, or maybe the other way today. But anyway, let's go back to the vacuum cleaner. It has some current sensing resistors, 6.8 ohms, 2 in parallel on the board. Here's the transistor, switching the motor and also pulse width modulating the power for the lower settings, I guess. And here's the microcontroller. It's some big microcontroller. Of course, the less readable the marking, the better. And there is also some TO982 package here. Just a small version of a 7805 regulator. And it's not on when the switch is off. This way it doesn't discharge the battery. And the input voltage is not the full voltage actually. And this powers the microcontroller, I guess. And this vacuum cleaner would be fixable, but I don't have the rotating brush. I don't need it anyway. I prefer a mains powered one anyway. It's horribly dirty. And I have a limited space, and if I choose to keep some electronics, I rather keep some vintage old school ones, not this modern clutter. So I keep the boards and motors and batteries and the screws, and the rest of it goes into a dumpster. And of course the video is getting bloody long. I wanted to open the battery pack and see what's inside of it, besides the cells, and measure their capacity and see how much they are degraded. But I will do it in a separate video. So that's it, and if you like the type of videos in this channel, please really consider supporting this channel on Patreon or using the thanks button, because that's how you keep this crazy channel running. And big thanks to all of you who already support me.